Welcome back, mathematicians. Today we're looking at one of the most important ideas in functions, the domain and the range. The domain is simply all of the x values that you're allowed to put into a function. And the range is all of the y values that come out onto the graph. In this lesson, we're going to look at a variety of functions, both linear, meaning straight lines, and nonlinear, meaning curvy lines, and figure out how to find the domain and range of each. This is our very first graph. You can see that it's a straight line. The graph goes through +5 on the y-axis, and it's an increasing slope. Now remember, domain is the set of all of x values. So exactly what does that mean? It means that if I go to the number 2 on the x-axis and I put 2 into the function, would I be able to travel straight from the number 2 and hit the line that is graphed? And I would. If I go straight up, there's going to be a point on the graph that I'm able to hit. I can do this for a variety of x values. Let's say I do -4. I would be able to go straight down. Now here's the part where it gets a little bit confusing, because of course we can't see the graph beyond certain numbers. So for example, x equals 10, we can't see that graph anymore, but we know this graph is continuing this way and this way, which means that I can imagine in my mind that if I draw a line straight up, eventually it will hit the graph somewhere off the page. That means that no matter how high I go up on the x-axis, all the way to infinity, I'm going to be able to find the line. That's also true for no matter how far I go down on the negative side of the x-axis, all the way to -infinity, I'm still going to find that graph down there. That means that we can list the domain as being from -infinity all the way to infinity. This is an interval notation. In other words, this is the smallest point and biggest point. But since that's all the points on the number line, we can actually also say all real numbers. This is something called a double stroke R. And double stroke R just means there are no restricted numbers. And that's our domain. So if we clear out the work that we did with our domain, let's do some work with range. Range are all of the y values that will hit the graph. So that means I'm going to go to the y-axis. Maybe I have the number 2 on the y-axis. The question is, can I draw a line that will reach the graph from the number 2? And the answer is yes. If I go to the number 8, can I draw a line that will hit the graph? The answer is yes. And just like how the graph continued to go up and down with the domain, it also continues to go up and down with the range. No matter how far down, all the way to -infinity, you can imagine that I will eventually get to the graph, as well as +infinity. I will eventually hit the graph. That means that my range is the same as the domain. And if your teacher is asking you to write it in interval notation, you're going to want to write it like this, even if you also write it like this. Let's look at a parabola. This is a standard parabola created by the function y equals x squared. So we're going to do our same trick for domain. I recommend actually going to the x-axis, both in the positive direction and the negative direction, and picking a number, and then seeing if you can draw an arrow from that number to the graph. And then just kind of imagine, what if you picked an even bigger number that wasn't on the graph? Am I still going to eventually be able to reach that function? And the answer is yes. On this side, it's going to continue to go up, so 6 will hit it. And if I go to the negative side, such as -8, it'll take a little bit longer, but it will eventually hit the function. There isn't a number on the x-axis that won't hit y equals x squared. That means our domain is -infinity to infinity, and can also be written as all real numbers. Now at this point I want to talk to you about a third way that you might see domain and range, and that's in inequality notation. Inequality notation is a lot like interval notation, but has inequality symbols in it. So you might also see domain written this way. It just means that all the x functions are between -infinity and positive infinity. Now let's talk about range. So we're going to clear our work with domain, and we're going to look at all of the y values that will hit the function. Remember, that means we're going to go to the y-axis and find a value and see whether or not we are able to touch the function from the y-axis. In this case, we are able to touch the function in either direction. And you can see that no matter how high up you go, you're going to be able to draw an arrow from the value to the function. However, as soon as we dip below 0, like with the number 2, we are no longer able to draw an arrow in order to hit the function. That means that this function doesn't exist below 0. The range starts at 0 and includes it, and goes all the way up to positive infinity. Notice that there is now a square bracket on 0 rather than a regular bracket or a parentheses. This is a square bracket. That means that it includes 0 and it goes up to infinity. So I cannot write all real numbers here. I can, however, write it in inequality notation because x is going to start at 0 and it's going to go up to infinity. So in other words, x are all of the numbers greater than 0, but it is also equal to 0. If I put 0 in for x, 0 comes out as y, and 0, 0 is our very first coordinate point, the vertex of this parabola. So our range is x is greater than or equal to 0, or from 0 inclusive to positive infinity. Let's do another one. At this point, I'm going to go rather quickly through all of these domains and ranges because I'd like to give you quite a few more examples so you have a lot of different examples that might show up on your homework or on your tests. So first of all, this function is y equals 4 sine x. You can see that it is a sine wave or a wave, and it maxes out at 4, minimums out at -4, but it keeps going and going and going in the x direction, both positive infinity and negative infinity. So I'm thinking about my domain in terms of what happens as it stretches this way. Every single time I pick a number on my x-axis, I'm going to hit that function. And it's not going to matter how far I go up or down. I'm going to continuously hit this because it's a sine wave. So the domain in this case is from negative infinity to infinity. We would say all real numbers, and in inequality notation, negative infinity all the way up to positive infinity. So let's do the range now. Remember, range is y, so I'm going to come to the y-axis, and I'm going to put in its maximum. If we put in its maximum, it hits it, but if it's above the maximum, it's not going to hit it. So it is not going to go up to the positive infinity direction or the negative infinity direction. It's going to minimum out at -4, and it's everything in between. So no matter where I hit the y-axis between, I will touch the function, but anything above and below 4, I will not. I want to be very careful too. This does cross through 4. So that means that it goes from -4 to +4, and that's inclusive. So I cannot write all real numbers because this is not every single number, but I can write this in both interval notation and inequality notation like this. The next function we're going to talk about is y equals 1 over x. And you can see that when we're talking about the domain, we're going to be able to hit numbers like this, or even -2. But if we try to hit the graph right exactly at 0, we are never going to be able to touch that line. That means that it can get closer and closer and closer to 0, but it cannot include 0. So we can write our domain as all real numbers except x cannot equal 0. Now, it's not very convenient to write this in interval notation, but if we really had to, we would write it like this and union it with this. So if you do have a teacher that's asking you to write this, this is the way that you would do it. Now let's talk about our range. Remember, range are our y values, so we're going to go to the y-axis and try and touch the graph. And you can see that no matter how high I go up, I am always going to be able to touch the graph, including right here, very, very close, but not exactly at 0. And so this range actually looks exactly like the domain. It's going to be all real numbers except y cannot equal 0. This graph is technically for the equation y equals log of x, but it has a lot of adjustments. First of all, it's not exactly log of x because it's been shifted away from its origin, but it also has been cut off. So we're not going to focus too much on exactly what this function is, and instead just talk about its domain and range. Domain, in this case, if I were to go out here, you can very clearly see that I'm not going to hit anything. If I go to exactly -3, that's where this starts. And it has a closed dot. That means it includes -3 in the domain. But after that, it's going to hit all the numbers above -3. So we can write that it includes -3 and goes up to infinity. We could also write it as inequality notation where x is greater than or equal to -3. Let's do our range. Remember, range is going to be y values If I go up here, you can see that this function is not going to hit it. In fact, it's not even going to hit 2. It's getting closer and closer and closer to 2, but as far as we can tell, it's never going to cross. It's also not going to cross anything below -1. But since that dot is closed, it's going to include -1. So this is a more complicated range. Let's figure it out. We always start with the smallest number. That's going to be -1. Since it has a closed dot, that's going to be a square bracket. It's going to go up and get closer and closer to 2. It's approaching 2, but it will never include 2. And although this looks a little bit funny, that's what we do. Now, for the inequality notation, we're also going to start at -1, and it's going to include -1, so we need the equal sign below. It is not going to include 2, and so we are going to write it as less than 2. For our very last one, we are going to work with something that isn't a function at all. I know it's not a function because we cannot have 2 inputs for a function. In other words, we're going to confuse a function if we put in -6, but sometimes get out 2 different answers. This is also known as the vertical line test. So if you're wondering what the vertical line test does, it really just draws a line and then travels up and down an equation to determine whether or not it's a function. If it hits twice, it means it's not. So we're not going to talk about what this function is, but we can still list its domain and range. So the domain is going to be x values, and if we put in -6, for example, we will hit something, but if we put in 0, or for that matter, anything greater than -2, we're not going to hit the function either. So that means that the smallest number is going to be -∞, but the biggest number is going to be -2 and will stop. And at this point, we can write that x is going to be less than or equal to -2. Now let's talk about our range. Range is from the y-axis, and no matter what I start at with the y-axis, I am going to hit the line, which means that the range goes from -∞ to +∞. You can see that even if I go up, this line is going to keep going up, and this line is going to keep going down. That means that I can write all real numbers, or that y is between -∞ and +∞. And that's our last question. Good luck with all of those domain and range problems that you might have.